once again, welcome back to the DSA with Dak series. Myself, Dak Patel, and today we're gonna solve question number 1534 of Leetcode. It's basically count good triplets. Okay, and yesterday we solved a question with where we are finding with the substring in a given word. Okay, all substring in our arrays of strings. How many substrings are possible? Okay, so in that question, basically the word is given and substrings of that word we have to check that is present in our given array of strings. Okay, and we have to return count of that. Okay, if it does not watch yesterday's video, you can check out that video, link in a button. And this is the DSA series where you can find DSA from the absolute beginner, okay, to advanced level. So one thing you have to do is you have to stay consistent to under each and every concept and to proper applying it. Okay, and try many things by yourself. Okay, so first I'll explain question. Afterward we see example. Then after we'll move to the uh, approach discussion part. We write a code and later on discuss about time and space complexity. So let's start without wasting any time. So the given an array of integers. Okay. So question given an array of integers of ARR. The array name is ARR and three integers. Okay. You have three integers A, B, and C. You need to find number of good triplets. So you have to do is find good number of good triplets. Okay. Find the number of good triplets. Okay. So a triplet. Okay. Triplet. What is triplet? So ARR of I, ARR of J, and ARR of K is a good triplet if the following condition are true. Okay, the given four condition are if true, your finding ARR of I, ARR of J, and ARR of K is a good triplet, and you have to increase count value by one. So first is I is greater than or equal to 0, J is greater than I, K is greater than J, and ARR dot length is greater than K. So basically the I is should be lesser than J and equal to or greater than 0, and K is greater than J and less than array dot length. Okay, so it's basically sequence there. One as is each and every one in sequence, increasing order of previous. Now ARR of I minus ARR of J modulus of that is less than and equal to A. Okay, so whenever you do ARR of I minus ARR of J, modulus of that should be less than or equal to A. Like that, you whenever you minus ARR of J minus K is less than or equal to B. Again, ARR minus I, ARR of I minus ARR of K is also less than and equal to C, where modulus of X denotes the absolute value of X. Okay, so return the number of good triplet. We'll see example one, so you got better clear about that. So input ARR 301197. Okay, and A equal to 7, B equal to 2, and C equal to 3. So our first triplet comes 301. Okay, 30 and 1 we taken. So afterward you whatever you have to do, 3 minus ARR of J and its modulus. So like that you have to do each and everything. Then you got your triplets. Okay, so here there is four triplets possible. They given you. So you have to return only for count of all possible good triplets. Now we'll see conditions. The length of array is between 3 to 100. Okay, not 1 to 100. It is between 3 to 100. And the value of error of I is between 0 to 1000. Okay, and A, B, and C all are between 0 to 1000. Okay, so I hope you got clear about the question and its example and okay everything. So now we'll move to the our approaches part. So firstly we'll discuss what approach. Okay, so now we'll move to the approaches part. So for this question, we're gonna use one approach. Okay, firstly there is one important approach is like as usual we use brute force method, but for this question it's a little bit complicated. You go with each and every approach. Each and every approach is complicated for this question. So first we use an outer for loop. Okay, so outer for loop work with the I. Okay, array of I. So it started from the first index to the n minus 2 index. Okay, n is the error dot length. Okay, so inside that we use one more for loop. Okay, middle for loop. This for loop started from the current I value plus 1 to the n minus 1 length. Okay, so middle for loop completed. Inside that we'll take condition. Okay, if condition, and then we use math dot observe and condition between that less than or not. Okay, and if first condition follows, the first given condition ARR of I minus ARR of j of modulus is less than and equal to a. If this follows, we inside take one more for loop. Okay, this for loop for k our last ARR of k, and just started from the j plus 1 ARR of j plus 1 to the k is less than n. Okay, and inside we use them as conditions 2 3, and if each and every was successful, so we use count plus plus, and at the end we return that count. Okay, it's look little bit weird, but this is the approach only for this question. So let me start with the this approach. So first whatever we have to need is count. Let count equal to 0, let n equal to arr dot length. Okay, now we have completed our first two things. Inside that, let I equal to 0, I less than n minus 2. Okay, I plus plus for let j is equal to I plus 1. Okay, j is less than of n minus 1 and j plus plus, and inside that we use if our mat dot observe is arr of I minus arr of j. Okay, wait, yes, if it's equal to this, so for we taking one more for loop. So here for let k is equal to j plus 1, k is less than of n, k plus plus, if our math dot observe arr of I minus arr of k is less than and equal to b, and then math dot arr of I minus arr of k is less than and equal to c. So count plus plus. Now we'll use here return. Okay, so now I'll run this to check each and everything is perfect or not. It's showing runtime error. Okay, so now it looks perfect. We'll run this to check each and everything is correct or not. So a wrong answer. Okay, looks fine each and everything. Let me run it again. Okay, it's correct. Might be some technical issue. Now we'll submit this to check for the lead code test cases. Okay, it's under process. Okay, you can see that our answer is accepted. All 92 out of 92 test cases are passed. So this is the approach. Okay, so this question is gonna use solve by one only one approach. Okay, this approach. So I'll explain one more time. Firstly, we use one more count variable to store currently count of the our good triplet pair. Okay, another one we take an length of the our array in n variable to simplify that outer for loop, which iterating from the first index to the last third index. Okay, afterward we use one more for loop which is starting from the our ith index plus 1. Now like currently I is on second index, so j start from the third index. Okay, and it will end on the second last index. Inside one, now we take one if condition. If this if one first condition modulus of arr of I minus arr of j is less than or equal to a. If these conditions follows, so inside one we have to take one more j loop to check if last conditions are follow or not, j minus k and I minus k. So now we'll move to this for loop with starting from the jth index plus 1 to the last index of the our array. So now inside one we take if condition. If these two conditions are followed, if the modulus of a ARR of j minus ARR of k is less than or equal to b, and also ARR of I minus ARR of k is less than or equal to c, so this condition is true and we increase the count value. It means it's good pair and we move to the next part. Okay, and at the end we return that count value. Okay, so this is the our only approach for this question. We'll move with the inbuilt functions and something like key value and like that, but the time and space complexity remains same for each and every approach in this question. So now we'll discuss about the space complexity used in this code. So space complexity is order of one. We using only two variables. None of out of that we using in this question. So our space complexity is order of n, order of one. Sorry, order of one space complexity is. Now we'll discuss about time complexity. So first loop, okay, so time complexity is order of n. Inside one another for loop from 0 to the n length, it's also order of n length, and third for loop is also from starting to the ending of the array, so it also contains order of n. So now our this code time complexity becomes order of n cube. Okay, but this question has like that, so it will accept order of n cube time complexity. Okay, and space complexity is order of 1. So this is the today's video. If you find any doubts about this video, you can ask me in comment section. Okay, I'll try to solve your doubts. Okay, and you can try this question by another approach, where, but the time and space complexity should be around this. Okay, n cube and order of one or order of n like that. Okay, I hope you got clear about each and everything. So now we'll move to the tomorrow's question part. Okay, so let's start tomorrow's question. So I'll open it tomorrow's question. It's basically 1816 question where we have to find truncate sentence, whether this given sentence is truncate or not. Okay, so the question is basically a sentence is a list, okay, of words that separated by a single space with no leading or trailing spaces. Okay, a sentence is a list of words that are separated by a single space with no leading or trailing space. Each of the word consists of only uppercase, okay, and lowercase English letters, no punctuations. Okay, the comma and the like other signs, no punctuation signs are there, but there is uppercase letters and lowercase letters in the word, and words are separated with the single white spaces. For example, hello word, hello and hello word, hello word are sentences. You are given a sentence S and an integer K. You want to trying to truncate S such that it contains only the first K words written S after truncating it. So whether you have given like hello, how are you, contestant, okay, and k equal to 4, so you have to write that hello how are you only 4. Okay, not each rest of that. Now wait, we'll see one more. What is the solution to this problem? So you have to write what is the solution. K is equal to 4, so you have to write only 4. Example 3, you can see that chopper is not a donkey, so k is equal to 5, so you have to write entire whole sentence. Now the length of the string is between 1 to 500. K is the range of one, the number of word in one s. Okay, so the k is between is the range of the number, and it's between 1 to the each and every words contained in a string. Okay, maximum of a string. S consists of only lowercase and uppercase English letters and spaces. The given string is consist of lowercase and uppercase English letters and spaces. The word in S are separated by single spaces. I'll tell you already. There are no leading or trailing spaces. So the question cleared you. They are no giving you a leading or trailing spaces. So you have simple things. So you can do that. So this is the tomorrow's question. You have to this question try. Okay. If you not solve, don't worry. You're gonna solve this question tomorrow. But you have to try. Okay. I know you can solve this question, and after completing this question, you have to post it on LinkedIn and Twitter and mention me. Okay. And if you not started yet, yes, there is link in a button from day one. You can start from day one where I'll explain each and everything about the series. To master DSA, you have to start from day one, and one thing you have to stay consistent to master DSA. Okay, come and each and every day you have to watch, understand questions, try to think about multiple approach. core logic. Okay, so this thing help you to improve your problem solving skills, and later on it will help you crack interviews and like that. Okay, so you have to stay consistent. Thanks for watching the video. Meet on tomorrow's video.